Hello and welcome to day 10 of Jamb Mathematics in 30 days. I believe it has been an wholesome experience starting from day 1 up until this very moment. And I want to say a big thank you to those of you that have been following the series so far. Keep your comments coming. Whatever question you would like us to answer, please ensure you put it in the comment section. We'll definitely attend to all of your questions and suggestions as well. Now, to those of you who are seeing this video for the very first time, this is Jamb Mathematics in 30 days. And with this series of videos, we believe that when you invest 30 to 45 minutes of your time daily, you can have everything you need to ace Jamb Mathematics. So we started from day 1 and this is day 10. So please do well to check out the videos from day 1 up until this moment so that you can have the full package. And of course, don't forget to like, share, drop your comments if there's any question you'd like us to answer and so on like that, and we will definitely attend to all of that. Now, day 10 is about matrices and determinants. Now, matrices in mathematics has to do with an array of numbers, symbols, letters that are arranged in rows and columns. And there are different types of matrices. You have your 2x2 matrix, 3x3 matrix, we have identity matrix, and so on like that. Just quite a lot of them. And to get a full knowledge of this matrix, you can check out our video still on this channel where we actually discuss matrices to a huge length there. So, but in this video, we're going to be focusing on what is expected of you when you are writing Jamb, right? And what Jamb expects you as a student to know before you take the exam on matrices as follows. Now, they expect that you should be able to perform basic operations such as multiplication of matrices, addition of matrices, subtraction of matrices, and division of matrices. That is, you have to be able to perform this operation on any kind of matrix that you are provided with. And then they also expect that you should be able to calculate the determinant of a square matrix. Now, it could be a 2x2 matrix, it could be a 3x3 matrix in this case, but you should be able to find the determinant of such matrices. And then finally, they expect that you should be able to compute the inverses of 2x2 matrix. Now, it is also possible to get the inverse of a 3x3 matrix and so on. But as far as Jamb is concerned, they limit it to 2x2 matrix. You know, the nature of the exam does not require long solving and things like that. So that is why it's limited to 2x2 matrix as far as inverses is concerned. So now that we've cleared that, let's go on to solve some past questions in Jamb concerning matrices. Let's go. This question is from Jamb 2009 and it says if Q is this 2x2 matrix that we see here with 9, -2, 7 and 4, then the determinant of Q is, so we have to find the determinant of this 2x2 matrix. Please take note that to find the determinant of a matrix, it has to be a square matrix before you can do that. And it's not only limited to 2x2 matrix, you can also find the determinant of a 3x3 matrix and so on. So, now, when you are finding the determinant of a 2x2 matrix, here is the way to go. Now, what you want to do is multiply them diagonally like this. That is, you have 9 multiplied by 4. And the result of that, you then subtract from that the multiplication of these two, this other diagonal here. Now, what I'm saying is that to get that determinant, you have to go 9 multiplied by 4, then minus. Now, what we have here is -7 multiplied by -2. So you see diagonal to diagonal. Now, 9 multiplied by 4 gives us 36, minus 7 times 2 would give us 14. So from here we have 36 minus 14, which would give us 22. So the correct answer is option C. This question says, if P is given by this matrix, where we have x plus 3, x plus 2, x plus 1, and x minus 1, evaluate x if the determinant of P, that is this matrix, determinant of this matrix, equals -10. Now, to solve this, that is, we are saying the determinant of x plus 3, x plus 1, x plus 2, x minus 1 equals -10. And as we did determinant of 2 by 2 matrix in the previous question, we're going to do the same thing here. So we do the diagonals, we multiply them. So that is, we're going to be having x plus 3 multiplied by x minus 1, then minus x plus 1 multiplied by x plus 2. And all of this equals negative 10. So now, let's expand. X times x gives us x squared. X times minus 1, that's minus x. 3 times x will give us plus 3x. Plus 3 times minus 1 will give us minus 3. Minus, now here, x times x, x squared. X times 2, that's plus 2x. 1 times x, that's plus x. 1 times 2, that's plus 2. All equals negative 10. Now open this bracket with a negative sign. So from here, we would have x squared. Now recall this is minus x plus 3x. That will give us plus 2x minus 3. Now minus times this will give us minus x squared. Minus times this will give us minus 2x. Minus times this will give us minus x. And then minus times 2 will give us minus 2. All equals minus 10. Now, let's tidy further. We have x squared here. This is another x squared, so minus x squared. Now, here we have plus 2x minus 2x minus x. Then, minus 3 minus 2 equals minus 10. X squared minus x squared, that's 0. 2x minus 2x, that's another 0. Now we are left with minus x here. Minus 3 minus 2, that's minus 5, equals minus 10. So we can then say minus x equals minus 10. Now when minus 5 comes here, it becomes plus 5. And it means minus x equals minus 5, which implies that x equals positive 5. So the correct answer is in option D. In this question, we are told that the determinant of this matrix is 15, and then to find the value of x. So determinant implies that we multiply by the diagonals. So that will be x multiplied by 7 minus 2 multiplied by 3, and this equals 15. This will give us 7x minus 6, and this equals 15. Thereby we have 7x equals 15. Now this becomes positive, so plus 6. That is 7x is then 21. Now what to do is to divide both sides by 7, which is the coefficient of x, and we see that x equals positive 3. That is in option A. Now let's find the determinant of this 3 by 3 matrix. Please, if you're yet to subscribe, kindly do so, as it helps us to be able to make more meaningful content like this all for you. So when we want to find the determinant of a 3 by 3 matrix like so, what we do is, now you see this first row, we label here plus, minus, and then this plus, intersecting it. So this would be our focus point here. You can also do the same thing if you want to start with the middle row or the last row like this, but I just prefer using the top row in this case. So what you're then going to do is you have 2 multiplied by the determinant of, now when you cross out row 1 column 1, that is, these numbers are crossed out like this. What we have is 6391. So in this order, right? And then we have this sign, so minus 0, then determinant. Now you cross out the row, the column under 0, and then still row 1 as well. Now you see that here you have 4, 3, 8, and 1. And then to the final one, plus 5, determinant. Now you cross out the column where 5 is, and then the top row as well. And you see that here we have 4, 6, 8, and 9. So I believe at this point you know what next to do. So let's just take it on. So now we would have 2 into 6 times 1, which is 6, minus 9 times 3, that's 27, minus 0 into 4 times 1, 4, minus 8 times 3, that's 24, plus 5 into 4 times 9, that's 36, minus 8 times 6, which is 48. Now, we know this is going to tend to 0, because 0 times anything gives us 0. So we'll focus on these two now. So we'll have 2 multiplied by 6 minus 27 will give us minus 21. Then plus 5 into, now 36 minus 48. Now in this case, we also have negative 12. Now, let's expand this. 2 times minus 21, this will give us minus 42. Plus times minus is minus. And then 5 times 12 is 60. And then when we do this, our final answer will be minus 102. So the correct option to pick here is C. In this question, we are told that if P is this 2 by 2 matrix where we have 2, negative 3 in row 1 and then 1 and 1 in row 2, what is the inverse of P? This symbolizes the inverse of P. So in order to solve this, there's a simple formula for inverse of P. We're told the formula says that P inverse equals 1 over the determinant of P multiplied by adjunct of P. So meaning we have to find the determinant of P and the adjunct of P. So determinant of P is determinant of this matrix 2 minus 3, 1, 1. And this will give us now 2 times 1, that's 2, minus 1 times minus 3, that's minus 3. Now this means we have 2 plus 3, which is 5. So the determinant of P is 5. Now to find the adjunct of P, there's a simple trick you can just do. Now when it's a 2 by 2 matrix, this only works for 2 by 2 matrix. So what you have to do is the element you have in row 1 column 1 and the one you have in row 2 column 2 will swap places. That is, you have 1 here and then you have 2 here. Now the other elements will just be multiplied by negative 1. Now minus 1 times 3 would give us 3, because minus times minus is plus. And then minus 1 times 1 will give us minus 1. So now we've gotten the adjunct of P. So P inverse would then be 1 over the determinant of P, that's 5, multiplied by the adjunct of P, 1, 3, minus 1, 2. Now let's multiply. 1 over 5 times 1, that will give you 1 over 5. 1 over 5 times 3 will give us 3 over 5. And 1 over 5 times minus 1 will give us minus 1 over 5. And 1 over 5 times 2 will give us 2 over 5. Now, when we compare with the options we have here, the correct one is in D. Here we are to find the value of x and y respectively, given that when we add these two matrices, now you see these are 2 by 3 matrices. When we added them together, it produces this result. So now the point of concern is just x and y. However, take note of this. Whenever you're adding two matrices together, they have to be the same. They have to have the same number of rows and the same number of columns. When you are doing addition and subtraction of matrices, they must have the same number of rows and the same number of columns, and they will always produce a result that has the same number of rows and the same number of columns. And what you do is that if it's addition or subtraction, you're going to add or subtract each element with its corresponding element in the other matrix. So that is, what we have here in row 1 column 1 will be added to what we have in row 1 column 1 of the second matrix, like that. 2 column 2 to 2 column 2 and so on, like that. So working with this, let's now to test this theory, let's look at those that we have the elements there. Like when you consider this particular element here, this is in row 1 column 3. We have 2. Row 1 column 3 of this is y. Here is x here. These are points of where we're going to focus on. But when we consider these ones that we have the digits here, this is 2 here and this is minus 2. And if you add them together, 2 plus minus 2 means you have 2 minus 2, and that's why you see we have 0 here. The same thing applies when you consider this now. Minus 1 plus minus 1, it means you have minus 1, which is minus 2. So you see the theory works. So, solution. Instead of adding the whole thing, I'm just going to focus on the elements that we are concerned about. Now, x and 1 are the corresponding elements here. So 1 plus x should give us minus 2. Now, what this implies is that x equals minus 2, then plus 1 comes here to become minus 1. So x is therefore minus 3. Now, apply the same thing to y. The corresponding element for y is 2 here. So 2 and y. So that is 2 plus y is what produces minus 3. Therefore, y becomes minus 3 minus 2. So y is minus 5. So our answer is minus 3, minus 5, and that is in B. Find PQ for which 2P8, 3 and minus 5Q multiplied by 1 and 2 here equals 24 and then minus 17. So to solve matrix like this, we're going to go this row against this column multiplied by this column, and then to the next row it will be this multiplied by this. Since this is only one column, so our work is cut out for us already. So we just go and write 2p then 8. This is 3 minus 5q. So let's multiply that into 1 and then 2. Recall that this would give you 24 according to the question and minus 17 here. So let's multiply. 2p times 1 gives you 2p. Now 8 times 2 will give us 16. Now we go to the next row. 3 times 1, that's 3. Minus, now remember you're supposed to add this. You're supposed to add the result. So plus, now minus 5q times 10, that's minus 10. So plus times minus remains minus, so minus 10q. Now, even though this looks like we have two numbers here, this is just one element here, 2p plus 16, and then 3 minus 10q is just one element, and it's the same as 24 and minus 17, meaning all of this is corresponding to 24, and all of this corresponds to this, right? So working with that, we'll then say 2p plus 16 equals 24. And from here we say that 2p equals 24 minus 16. Which implies that 2p equals, now 24 minus 16 will give us 8. So dividing both sides by 2, we then say p equals 4. Now to find q, we go to the next one where we have 3 minus 10q equals minus 17. So I'll take minus 10q to this side and then bring minus 17 here. Minus 10q here will make it positive, so we would have 10q equals, we have 3 here, then minus 17 becomes plus 17. So 10q equals 20. Now dividing both sides by 10, and we see that q equals 2. So our answer is 4, 2, and that makes it option C. In this question from 2006, we're given two 3 by 3 matrices, X and Y. And then we're asked to find 2x minus y. What this means is that we're going to multiply x by 1 here, by 2 rather, this 2 being a constant. So multiply by matrix X, then minus matrix Y. So to solve this, let's first multiply matrix X by the constant 2. So 2 multiplied by matrix X. Remember, matrix X is 1, 0, 1, 2, minus 1, 0, minus 1, 0, and 1. Now, when you are multiplying a constant by a matrix, you just multiply the constant by the individual elements in the matrix. So this will be 2 times 1 to give you 2. 2 times 0, that's 0. 2 times 1, 2. 2 times 2, 4. 2 times minus 1, that's minus 2. 2 times 0, 0. 2 times minus 1, minus 2. 2 times 0, 0. 2 times 1, 2. So this is twice of x. Now what we're going to do is twice of x minus y. So that is, we're going to have this, which is 2, 0, 2, 4, minus 2, 0, then minus 2, 0, and 2. Then from it we'll subtract matrix y, which is minus 1, 1, then 2. Then we have 0, minus 1, minus 1, then 2, minus 1, then 1. Now what we do here is we subtract the corresponding elements. So that is what we're going to have is 2 minus minus 1. That's basically 2 plus 1, which will give us 3. Now 0 minus 1 will give us minus 1. 2 minus 2 will give us 0. Right? Now to the next row we go. 4 minus 0, that's 4. Minus 2 minus minus 1, this becomes plus 1. So minus 2 plus 1 will give us minus 1. And then 0 minus minus 1. Minus times minus becomes plus here. So 0 plus 1, that's 1. Now minus 2 minus 2, that will give us minus 4. 0 minus minus 1. Minus times minus, that's another plus. So 0 plus 1, 1. 2 minus 1, 1. So we should have 3 minus 1, 0. All these have the same thing there. So then 4 minus 1, 1. So the only one that has that is B. And then we can then check the last one. Minus 4, 1, and 1. So it's exactly what we have in B. So that's our answer. Find matrix A if matrix A multiplied by this other matrix produces this result. Now, this question is from 2023, and we're having two matrices multiplying into each other to produce this, but we do not know one of the matrices. So let's find the matrix A. Now, since we do not know the elements of matrix A, we're going to assign letters to replace the positions of those elements. But one thing we know for sure is going to be a 2 by 2 matrix, because only a 2 by 2 matrix will multiply by another 2 by 2 matrix to produce a 2 by 2 matrix like this. So we say let matrix A. Now take note, matrices are written with capital letter, but the elements are written in small letters. So let matrix A be A, B, C, D. You can make yours X, Y, W, X, Y, Z, any letter you want. It works. So once we have this, therefore A, B, C, D multiplied by this other matrix 0, 1, 2, minus 1 should produce 2, minus 1, 1, and 0. So let's work with this. So starting with row 1, A times 0, that's 0. B times 2, that's 2B, plus 2B. Then we do the same thing now to this. A times 1, that's A, plus B times minus 1, that's minus B. So straight up minus B like this. Now we go to row 2. C times 0, that's 0, plus D times 2, that's 2D. Now to this, C times 1, that's C, and then d times minus 1, that's so plus minus d, that's minus d. So now that this is done, we then equate it to 2, then minus 1, 1, and then 0. Now taking note that this element we have here is the same as 2. This element here, a minus b, is minus 1. 0 plus 2d is 1, and then c plus d is 0. So we can then say 0 plus 2b, that will give us 2b. So 2b equals 2, and this implies that b is 1. Okay? So if b is 1, then we can say a minus b, which is 1, equals minus 1. So a would therefore be minus 1 plus 1, which is 0. So we have gotten b, we've gotten a. Now let's get d here. 0 plus 2d will give us 2d. So 2d equals 1. Therefore, d would be 1 over 2. Now applying that here, we would have c minus 1 over 2 should give us 0. Therefore, c equals 1 over 2. So in that case, matrix A would then be, now coming back to this, A is 0, B is 1, C is half, and then D is also half. So we've gotten matrix A, and this is similar with what we have in option B, so we select option B. So we have matrix A given here, and then matrix B given here, and we have to find A plus 2B. So what we'll first do is to evaluate 2B. So that is, we're going to be having constant 2 multiplied by matrix B. That is 2 into matrix B, which is 1, 4, minus 2, minus 3, 3, and minus 1. So given this now, let's then evaluate this out. So we'll have 2 times 1, that will give us 2 here. 2 times 4, that's 8. 2 times minus 2, that's minus 4. 2 times minus 3, that's minus 6. 2 times 3, 6. 2 times minus 1 is minus 2. Now what we have to do next is then find A plus 2B. So A plus 2B would imply that we have this matrix A now. 2 minus 4, 3. Let me space this properly. So 5, 1, and then 0. Plus 2B, which is 2, 8, minus 4, minus 6, 6, and minus 2. Now this would give us 2 plus 2, 4. Minus 4 plus 8, 4. 3 plus minus 4. That will give us minus 1. 5 plus minus 6, minus 1. 1 plus 6, 7. 0 plus minus 2, that is minus 2. Now, given this answer then, the correct option is A. So this question from Jamb 2024 says that if A is this certain 2 by 3 matrix and then B is this 3 by 2 matrix. So we have to add the transpose of A and B. Now, I've mentioned before in this video that you cannot add two matrices that do not have equal number of rows and columns, right? So that is, we can't do a 2 by 3 plus a 3 by 2. So you will have to find the transpose of the other. That is why the question asks us to find the transpose of A, and then we add B to that. So this is how we find the transpose of a matrix. So A transpose will be given by, now the rows and columns are going to switch places. That is, row 1 becomes column 1, row 2 becomes column 2. So transpose of A would then be, now row 1 will be column 1 as 3, 2, and 1. And then row 2 will become column 2, which will be 4, 2, and minus 1. Now we've gotten the transpose of A. So transpose of A plus B implies that we are having this 3, 4, 2, 2, 1, and minus 1 plus the elements in B, which is 1, 4, 0, 1, 3, and 2. So when you're adding matrices like this, we add the corresponding elements. So 3 plus 1 would give us 4. 4 plus 4, that is 8. 2 plus 0, 2. 2 plus 1, 3. 1 plus 3, 4. Minus 1 plus 2, that is 1. So what we have here is 4, 8, 2, 3, 4, 1. And when we compare with the options that we have, the correct option is D. 4, 8, 2, 3, 4, 1. So our answer is D. Now, to get more question and explanation on matrices, check out our video on matrices. In that video, we explain a whole lot more about matrices other than this. And also do well to check every other videos that we have in mathematics to become a master at mathematics with Oya Learn. And don't forget to like, share, and subscribe to this video. See you in the next one.